Agent Amigos presents the model router, how NVIDIA's Nemo Switchyard picks the perfect AI for every job. A story worth hearing, stay with us. In 2026, a new AI model drops every week, each one claiming to be the best thing since sliced bread. Last month alone, we saw DeepSeek V4 with 1.7 trillion parameters, Qwen 3.8 Max with 2.4 trillion, and Grok 4.6 from xAI. That's not even counting the smaller ones like Cactus Needle, which runs on a Raspberry Pi. The sheer number is overwhelming. Here's a staggering fact: the cost to run these models varies wildly. DeepSeek V4 costs about 6 cents per task, while Gemini 3.7 Flash comes in at 40 cents. That's a six-fold difference. And the performance? Also all over the place. Some models crush coding benchmarks, others are wizards at creative writing, and a few are just plain fast. So what's a developer to do? You could pick one model and hope it's good enough. But that's like hiring a single employee for every job in your company, a chef to do your taxes, a plumber to perform surgery. It's inefficient and expensive. The smart move? Use a router. Not the kind in your Wi-Fi, but an AI model router that looks at each task and decides which model is best suited for it. And that's exactly what NVIDIA's Nemo Switchyard does. It's a significant shift, and by the end of this talk, you'll see why. But first, let's rewind. How did we get here? It wasn't too long ago that we had just a handful of models. Now we're drowning in choices. With that settled abundance comes a new problem: decision fatigue. That's where Nemo Switchyard comes in. Most people think you just pick the biggest, baddest model and you're set. But that's like buying a semi-truck to go grocery shopping. Sure, it gets the job done, but it's overkill and burns a hole in your wallet. Let me give you a concrete example. Say you're building a chatbot that needs to answer customer questions. Some questions are simple: what's your return policy? Others are complex: can you explain the tax implications of this investment? A small, fast model can handle the simple ones in milliseconds. A huge, slow model might take seconds but gives a more nuanced answer. If you use the big model for everything, you're paying premium prices for trivial queries. That's like using a Ferrari to deliver pizza. It's fun, but you're losing money on gas and maintenance. And it's not just about cost. Different models have different strengths. For example, Qwen 3.827b is a local GPU king. It beats Opus 4.6 Max on some benchmarks and runs on a single GPU with just 9 GB of memory. Meanwhile, DeepSeek V4 is the best intelligence per dollar, tying with much more expensive models. So why not use each where it shines? The problem is, manually routing tasks to different models is a nightmare. You'd have to write custom logic for every type of query, test it, and update it as models change. That's where a smart router comes in. It learns from your tasks and automatically picks the best model, saving you time and money. And that's exactly what NVIDIA's Nemo Switchyard does. It's like having a traffic cop for your AI requests, directing each one to the right model. But how does it work? Let's explore the details. So, what exactly is Nemo Switchyard? It's a model router, part of NVIDIA's Nemo framework, announced alongside Nematron Lightning, a 30B mixture of experts model that's the fastest in its class. But Switchyard is the unsung hero. It's the brain that decides which model to use for each task. Imagine you have a fleet of delivery vehicles, a sports car for quick local trips, a van for medium loads, and a big truck for heavy cargo. Switchyard is the dispatcher who looks at each order and sends the right vehicle. In the AI world, the vehicles are models like GPT 5.6, Claude, or the open-source Qwen models. What makes Switchyard special is that it's designed to be model agnostic. It doesn't care if you're using NVIDIA's own Nematron or a competitor's model. It just knows how to route. And it's not just a simple if-else statement. It uses machine learning to predict which model will give the best response for a given input. Here's the kicker: it's 3 times cheaper than using a single powerful model for everything. That's a huge deal for startups and enterprises watching their cloud bills. But don't just take my word for it. The NVIDIA blog post says it picks the best model per task, 3x cheaper. That's the headline. And in the world of AI, where costs can spiral out of control, that's music to any CTO's ears. Now, you might be wondering, how does it actually decide? That's the million-dollar question, and we'll get to that in the next chapter. So how does Nemo Switchyard know which model to use? It's not magic, it's a combination of heuristics and learned behavior. At its core, it evaluates the task at hand and scores each available model on how well it's likely to perform. Think of it like a restaurant maitre d' who knows the menu inside out. When a customer asks for a vegan dish, they don't recommend the steak. They have a mental map of what each dish is good for. Switchyard has a similar map for models. It looks at factors like the complexity of the prompt, the desired response length, the domain, like code versus creative writing, and even the latency requirements. Then it assigns a score to each model based on historical performance and current load. But here's the clever part, it learns over time. The more you use it, the better it gets at predicting which model will succeed. It's like a seasoned chef who knows exactly which pan to use for each dish. And it's not just about accuracy. It also considers cost and speed. If 2 models are equally good, it'll pick the cheaper one. If you need a response in under a second, it'll avoid the slow, heavy models. The result? You get the best possible response, at the lowest cost, in the shortest time. It's a win-win-win. Of course, this isn't trivial to implement. But NVIDIA has done the heavy lifting, so you don't have to. You just plug in your API keys and let Switchyard do its thing. Let's talk numbers, because that's what gets executives excited. The NVIDIA blog claims that using Nemo Switchyard can cut your AI costs by 3 times. How? By not wasting money on expensive models for simple tasks. Here's a simple example. Suppose you have 2 models, a small, fast one that costs 1 cent per 1K tokens, and a large, slow one that costs 10 cents per 1K tokens. If you route 80% of your tasks to the small model and only 20% to the large one, your average cost drops to $0.028 per 1K tokens. That's a 72% reduction. And that's not even accounting for the fact that the small model might be just as good for many tasks. In fact, a study by NVIDIA found that for a typical workload, the router can achieve 95% of the quality of the best model while using only 30% of the cost. But it's not just about the per token cost. It's also about throughput. If you're using a large model for everything, it can get overloaded, causing delays. By distributing the load across multiple models, you can handle more requests per second with the same infrastructure. Now, you might be thinking, that sounds great, but is it reliable? The answer is yes, because Switchyard is designed to handle failures gracefully. If one model goes down, it routes to a backup. It's like having a spare tire in your trunk. So, if you're a startup trying to keep your burn rate low, or an enterprise trying to optimize your AI spend, this is a no-brainer. And the best part? You can start using it today with minimal setup. Speed is the name of the game in AI. Users expect instant responses, and if your chatbot takes 5 seconds to reply, they'll get frustrated and leave. That's where Nemo Switchyard shines. Consider this. GPT 5.6 Sol can generate 750 tokens per second with Cerebra's hardware. That's blazing fast. But it's also expensive. On the other hand, a small model like Cactus Needle runs at 500 tokens per second on a Raspberry Pi, but it's not as smart. Switchyard can route simple queries to the fast, small model, giving you sub-100 millisecond responses. For complex queries, it can send them to a larger model, even if it takes a second or 2. The key is that the user perceives the response as instant because most queries are simple. Comparing to other routers, Imagine you're using a voice assistant. You say, "What's the weather?" You don't need a 70 billion parameter model for that. A small model can handle it in a flash. But if you ask, "Explain quantum entanglement," you want the big guns. Switchyard makes this seamless. It's like having a sports car for city driving and a limo for highway cruising. You get the best of both worlds. And it's not just about user experience. Speed also affects cost. Second, content generation. A marketing agency might need to write product descriptions, blog posts, and social media updates. Each has different requirements. A short tweet doesn't need a 200 billion parameter model, but a detailed white paper does. Switchyard can pick the right tool for each job. Third, code generation. Developers use AI to write code, but not all code is equal. A simple function can be generated by a small model, while a complex algorithm might need a state-of-the-art model like DeepSeek v4. Switchyard can route accordingly, saving time and money. Fourth, in robotics. Dyna 2, a world action model, trains robots using 1 million hours of human video. For instance, if a request is simple, say, summarizing a short email, Switchyard might route it to a smaller, faster model like Nematron Lightning's 30B Mo, which excels at speed. But for a complex coding challenge, it would escalate to a frontier model. This dynamic selection is what drives the 3x cost reduction, because you're not paying flagship prices for trivial tasks. The system continuously learns from outcomes, refining its decisions over time. It's not just a static lookup table, it's an adaptive brain that gets smarter with every query. And because it's built on NVIDIA's stack, it integrates seamlessly with existing AI pipelines, making deployment a breeze. The technical beauty lies in its simplicity. Underneath the complexity, it's just smart routing, but that simplicity is what makes it so powerful. Under the hood, latency is a critical design constraint. The router itself adds minimal overhead, think milliseconds, so the speed gains from using the right model aren't negated by the routing decision. This is achieved through efficient caching and parallel processing. The system can pre-route common queries, storing decisions for instant reuse. It also uses predictive models to anticipate user needs, further cutting response times. For developers, the API is clean and straightforward, with comprehensive documentation and SDKs for major languages. You can set custom policies, like always using the cheapest model for internal tools, or prioritizing speed for customer-facing apps. The architecture supports both cloud and on-premises deployments, giving enterprises full control over their data. Security is baked in, with encryption at rest and in transit, plus fine-grained access controls. And because it's open source, the community can inspect and optimize every layer. This transparency builds trust and drives innovation, as developers can contribute improvements or fork the project for niche use cases. In a world where AI models are proliferating, Switchyard's architecture is a blueprint for managing the chaos. Nemo Switchyard isn't the only router on the block, but it's carving out a distinct niche. Other solutions, like open-source routers from startups or proprietary ones from cloud providers, often focus on either cost or speed, but rarely both. Switchyard's edge is its tight integration with NVIDIA's hardware and software ecosystem. For example, it can leverage TensorRT LLM for optimized inference, something. But when the robot is in the field, it needs to make split-second decisions. Switchyard can route sensor data to a fast, lightweight model for immediate reaction, while offloading complex planning to a more powerful model. These are just a few examples. The possibilities are endless. Any application that uses AI can benefit from intelligent routing. And as we'll see in the next chapters, the technology behind it is only going to get better. Peeling back the hood, Nemo Switchyard isn't magic, it's a sophisticated piece of engineering that thinks before it routes. At its core, it's a lightweight model that evaluates incoming requests and matches them to the best-suited AI model from a pool. Think of it as a dispatcher with a supercomputer's intuition. The architecture leverages NVIDIA's ecosystem, meaning it's optimized for their hardware, from data center GPUs to edge devices. The router uses a scoring system that weighs multiple factors: task complexity, latency requirements, cost constraints, and model capabilities. The faster a model responds, the more requests you can handle per second, which means you need fewer servers. That's another way to save money. So, if you're building a real-time application, like a live translation service or a gaming NPC, Switchyard can help you meet your latency targets without breaking the bank. Let's look at some real-world scenarios where Nemo Switchyard can make a difference. First, customer support. Companies like banks and telecoms get thousands of queries a day. Most are simple: what's my balance? How do I reset my password? A small model can handle these instantly. But occasionally, there's a complex issue that requires a human-like understanding. Switchyard routes those to a larger model, ensuring the customer gets a helpful answer. Thank you for watching Agent Amigos. If this talk sparked something in you, hit like, subscribe to Agent Amigos, and share it with one person who needs to hear it. Knowledge is better when it is shared. See you at the next talk.